Yeah, so this goes your next question. That is, we need to find the half range cosine series for the function f of x is equal to pi minus x in the interval 0 to pi. So the interval given is 0 to pi, and in cosine series we know that it corresponds to an even function, and in even function the values of Fourier coefficient bn is equal to 0, and we need to find the values for a0 and an. So we'll find the values for a0. So this is a formula to find a0. 2 by pi 0 to pi. The f of x given is pi minus x dx 2 by pi. So integrate the function, that is pi x minus x square by 2 from the interval 0 to pi. a0 is equal to 2 by pi into first the upper limit, that is pi into pi is pi square minus pi square by 2 minus the lower limit is 0, right? So I'll write it as 0. 2 by pi into, so take the LCM, it becomes 2 pi square minus pi square by 2. Cancel this 2, so a0 is equal to 2 pi square minus pi square is pi square by pi. You can cancel 1 pi, so the required value of a0 is equal to pi. So now we will find an. So this is the formula to calculate an. 2 by pi 0 to pi, the value of f of x is pi minus x cos nx dx. So now apply the Bernoulli's rule. First function as it is into the integration of second function, integration of cos is sin nx by n minus the differentiation of this function. In differentiation of pi is 0 and x is minus 1, so minus of minus 1 into integration of sin is cos nx by n square, limits from 0 to pi. So now first substitute the upper limit, that is pi minus pi is 0, sin n pi by n, minus into minus plus into minus, again minus cos n pi by n square minus the lower limit, that is 0. Pi minus 0 is pi, sin n pi by n, again minus into minus is plus, plus into minus is minus cos, so this is 0, right? Pi sin 0 by n minus cos 0 by n square. So the required answer we get here is, so we can cancel some terms, that is this is 0 and this is 0, sin n pi is 0 and sin 0 is 0. So the remaining terms are minus cos n pi by n square, minus into minus is plus cos 0 by n square. So take 1 by n square common outside, so it becomes 2 by pi n square. The remaining terms are minus of cos n pi, for value is minus 1 to the power n plus 1. So this is your required an. Okay, so now let's write the Fourier series here itself, that is a0 by 2, so pi by 2 plus summation n tends to 1 to infinity 2 by pi n square 1 minus of minus 1 to the power n cos nx. So this is your required Fourier series. This is n, okay? Yeah. Okay, so this goes your next question. Yeah, so this is your next question. That is the very important question and the repeated question. You can say that this is a sure question. This question might come for exam as well. Okay, only the values might be here and there. Okay, so the question is, the following table gives the variation of the periodic current A over a period T. Okay, so they have given the tabular column of time and amperes. So they have given as 0, T by 6, T by 3, T by 2, 2T by 3, 5T by 6 up to T. So here we can see that the limit is from 0 to t. Okay, instead of 2 pi it is t. So we can directly say that the period is equal to, not equal to 2 pi, but the period is equal to t. Okay, because in the question it's given us over a period t, and we know that if the period is not equal to 2 pi, we should write as period is equal to 2l, right? Should write period is equal to 2l, right? Yeah, but the question not completes here. So again there is a few parts, that is we need to show that there is a direct current part flowing that is equal to 0.75 ampere. So that we need to show that the constant term which we get, right, that should be the double of the direct current part. That is, we know that the final Fourier series will look like a naught by 2, right? A naught by 2 into the into the harmonics, right? So the value of a naught we get should be the double of this 0.75. That is, we need to get the value of a naught, that is the constant term, as double of 0.75 is 1.5. So that we can prove that, they have tell us to show that the direct current part is 0.75. That is, after while writing the Fourier series, we need to write it as 1.5 by 2, right? Because we are assuming that the answer should be double of this, that is 1.5 by 2. 1.5 by 2 is again 0.75. That only we need to prove that in the Fourier series the value of the constant a naught by 2 we get is 0.75 in the variable current, and obtain the amplitude of the first harmonic. That is, we need to find the first harmonics. Okay, so here the values of a and at t is equal to 0 and at t is equal to time t are same, hence we can neglect the last one. Here we can see that the first and last values are same, 1.98. so the observations also becomes one lesser than the total, that is n is equal to 7, right? So now it becomes 6, and we know that the period is not equal to 2 pi, it's equal to 2l, and also the period is given as t, so equate it. 2l is equal to t, the value of l further we get it as t by 2. Now the theta we know that is equal to pi x by l, but in this case it's not x, right? The parameter given is time t, so the theta we need to substitute as pi t by l. Okay, so pi t by the l value is t by 2, so bring this t by 2 to the reciprocal, so the value theta finally we get it as 2 pi t by t. Okay, yeah, so now we need to find the parameters, right, to find the harmonic analysis and constant term. For that put the tabular and write the time values and amperes. Theta is equal to 2 pi t by t cos theta, a cos theta, since there is no y, there is a, right? So we need to multiply by a sin theta and a sin theta. Okay, so after that sum up all the, in order to find the constant term, the formula is 2 into summation of a by n, right? So summation of a, we need to find the summation of a. Yeah, so let's cross check the answers which we are getting as 4.547. okay, so let's cross check it. 1.98 plus 1.3 plus 1.05 plus 1.3 minus 0.833 minus 0.25. Yeah, the answer we got is matching, 4.547. So now again we need to find the values for theta. Substitute the value of small letter t. So first it is 0, 2 pi into 0 by t, that is 0 by t is 0 degree. Then t by 6, that is the value of small t we need to substitute as t by 6, so the which we get is 2 pi by t into t by 6. So these two gets cancelled, the remaining answer we are getting is 2 pi by 6, right? So pi by 6 we know that it is 30 degree. 30 degree into 2, that 2 pi by 6, that is equal to 60 degree. Similarly for all the parameters we need to find, with the degrees we get is 60, 120, 180, 240 and 300. After that we need to substitute the values for cos theta, and a cos theta means we need to multiply 1.98 into 1, and all these things we need to multiply and we need to fill this tabular. After that we need to sum this up in order to find the summation of a cos theta to find the harmonics. Okay, so now let's cross check this as well. 1.98 plus 0.65 minus 0.525 minus 1.3 plus 0.4165 minus 0.125. Yeah, the answer is 1.0965. So now again for sine theta, and also same goes for a sine theta. Yeah, so now we need to find the values for 2 into summation a by n. Okay, summation a, we know that it's 4.547, 2 1s are, 2 3s are. So we can simplify the answer, we get is 4.547 by 3, 1.515, right? Similarly goes for this one, 3, 1.0965 divided by 3, 0.3655. Correct, right? I'm just cross checking my answers. So yeah, these are the direct formulas to apply. We have discussed in our classes, right, about these things. Okay, yeah, again 2 1s are, 2 3s are, 2.9729 divided by 3. Yeah, we get it as 0.9909. Okay, put it as 0.9909. After that, find the first harmonic. The formula for first harmonic is a1 cos theta plus b1 sin theta. Substitute the values for a1 and b1 and write it as cos. The value of theta we have got it here is 2 pi t by t. Substitute it. Then the final parameter is usually it was f of x, right? Here it is a of t, because the question is in the form of a of t, right? So here we can see that the parameter we got is 1.515 by 2, which is approximately equal to 1.5 only, right? So yeah, if we divide it, we get it as 0.75. That only we need to prove that the direct current flowing through the part of the variable current in the given parameters are, the given value was 0.75, we got it as 0.75 along with the first harmonic. Okay, yeah, so this is the solution. Okay, so this is your next question. Okay, please look at this question, please look at whatever I've written here, and please get this straight into your head, because this question is a sure question. I will bet how much ever you want, this question will come for exams. Okay, so please listen to this. This question is a sure question that this will come for the final exams. Okay, the question goes like this: u of z is equal to 2z square plus 3z plus 14 divided by z minus 3 the whole cube. If it's given, this question will come for exam. I guess the values here might change, this might remain the same, z minus 3 whole cube, and now we need to find the values for u1, u2 and u3. Okay, so in order to find the value of u1, we know that u1 formula is z into u of z minus u naught, right? Yeah, so please listen to this question very carefully. I have already solved this and kept it to you, because if we go to solve this question, it might take around more than half an hour or something, because there are many calculations here in this problem. Okay, so I have written it down and I am going to explain it to you. Yeah, so in order to find u1, we need the value of, we need to find u naught, right? So first we need to find u naught. The formula for u naught goes like this: u naught is equal to limit z tends to infinity into u of z. So u naught is equal to limit z tends to infinity. Substitute the value of u of z, 2z square plus 3z plus 14 divided by z minus 3 whole cube. After that, limit take z square common in the numerator outside. The remaining terms are 2 plus z square we took common, right? So we need to divide by z, and here again z square, if we take common, the term which we need to divide is z square. Again in the denominator, again take z cube common and write it as 1 minus 3 by z the whole cube. Okay, and after that we can cancel z square and z cube, and one z remains in the denominator. Write it z into 1 minus 3 by z the whole cube. After that, take this limit out and substitute z tends to infinity. So substitute the value of z wherever there is z, substitute as infinity. That is 2 plus 3 by infinity plus 14 by infinity square. Infinity, the whole square is infinity itself only, right? Yeah. Divided by infinity into 1 minus 3 by infinity the whole cube. That is anything to the power of anything divided by infinity is 0, right? anything by infinity is 0, right? So it gets 2 by infinity into anything is again infinity, so anything to the power infinity, again we get it as 0. So the final u0 we got here it as 0. After that, this is not the aim. We need to find the values. In the question it's given that u1, u2 and u3. This we are only doing to find the value of u1 here, because in order to find u1 we need to know u0. Okay, so this is the formula for u1. Limit z tends to infinity, z into u of z minus u0. Okay, we have discussed this during the properties, okay, the formulas. So you need to remember this. u1 is equal to limit z tends to infinity, z into u1 is equal to z into the substitute the value of u of z, and u0 is 0, right? So I have not written it again. So again take z square outside. Since there is already a z outside, so it becomes z cube, right? There is already z outside. If we take z square again outside, it becomes z into z square, it is z cube. And write the terms again as it is in the form 2 plus 3 by z plus 14 by z square divided by, again take z cube outside in the denominator and write it as 1 minus 3 by z the whole cube. And z cube gets cancelled. The remaining term is 2 by 3 plus z plus 3 by z plus 14 by z square divided by 1 minus 3 by z the whole cube. Again take the limit and substitute the limits as infinity, and this becomes 3 by infinity is again 0, anything by infinity is 0, and 1 minus 3 by infinity is again 0, 1 minus 0 the whole cube. So 2 by 1 minus 0 is 1 and 1 cube is 1, so 2 by 1. So the answer here we got for u1 as 2. Okay, so now we found the value of u1 now. So again it's not done yet. Now the tricky part and the tough part comes ahead for you. So yeah, the next thing we need to find is u2. Okay, so this is the formula for u2. Limit z tends to infinity, z square into u of z minus u0 minus u1 z inverse. Okay, so substitute the values. Here z square is not common for this term. Okay, we need to take z square separately. Okay, and we need to put a bracket. So this whatever is there in this bracket, for that we need to solve, and we should not touch this z square during the whole process. Okay, keep this as it is, and when the last step comes you need to take that z square into the condition. Okay, so now substitute the value of u of z, that is 2z square plus 3z plus 14 divided by z minus 3 whole cube, minus u0 is 0, I have not written it, u1 into z inverse. Okay, this z inverse, when it goes to the denominator it becomes z to the power 1, that is equal to z, and the value of u1 which we got right just now is 2, so it is 2 by z. Now again in the brackets take the LCM, that is we need to multiply this term by z, so it becomes 2 into z square, it's multiplied by z, so it becomes z cube, this becomes z square, and this becomes 14 into z, minus cross multiply 2 into z minus 3 the whole cube divided by multiply the denominator z into z minus 3 whole cube. And after that again the simplification for the LCM, and now to keep this term as it is, 2 into, now we need to know the formula of a minus b the whole cube in this case. Okay, please study the formula of a minus b the whole cube. That is, the formula goes like this, that is the formula for a minus b the whole cube is a cube minus 3 b cube minus 3a square b plus 3ab square. Okay, this is the identity for a cube minus b cube, that is a cube minus a minus b the whole cube, that is a cube minus b cube minus 3a square b plus 3ab square. Okay, yeah, that identity we need to apply here, and the answer we get is z cube minus 9z square plus 27z minus 27. Okay, yeah, after that again we can cancel out some terms, multiply 2 to this term, we get it as 2z minus 2z cube plus 18z square minus 54z, 27 to the 54, right, plus minus into minus is plus, so plus 54 divided by z minus z into z minus 3 whole cube. So here we can cancel 2z cube, and the remaining terms are z square, keep it outside. So here the 3z square plus 18z square, 18 plus 3 is 21, 21z square, and again 14z minus 54z will give you minus 40z, and this plus 54 keep it as it is, and z divided by z minus 3 whole cube. Now take this z square outside. Okay, so now this becomes z square into z square, and the remaining terms are 21 minus, we are taking z square outside, so it becomes 40 by z plus 54 by z square divided by z, this z is outside right here, into, again take this in this we can take z cube outside, so it becomes z into z cube, again 1 minus 3 by z the whole cube. Again we can cancel, if we multiply z square into z square, that is equal to z power 4. This is also is equal to z into z cube is equal to z power 4. So we can cancel these two, z power 4 and z power 4. So the remaining terms are, so the remaining terms are 21 and 40. Substitute the limit, that is it will be becomes to 40 by infinity. Anything by infinity is 0. We get it as 21 by 1, and after that we get the value of u2 as 21. So similarly, same thing again, we need to find the value of u3, but here we have some long procedure to follow, because the LCM carries it's very tricky, and we need to know, we need to see all the terms very carefully. Okay, there are some huge terms here. Okay, so I am going to tell you guys. So here the formula is z cube into u of z minus u naught minus u1 z inverse minus u2 into z to the power minus 2. That I have not written the formula, that's it. So here again z cube, in the whole process keep z cube outside, and in the last step we need to consider it. Okay, and again substitute the value of u naught, substitute the value of u naught is 0, u1 is 2 by z to the power 1, right, so by z, and again u2 is 21 and z to the power minus 2. When it comes to the denominator, it becomes z square. Again take the LCM, multiply all the common denominators, so it becomes z into z square is z cube into z minus 3 whole cube. Again take the LCM and see that which term is missing here. Z minus 3 whole cube is there, z cube is missing, right, so we need to multiply this term, this numerator term, by z cube, so it becomes 2z square by z, 2z square into z cube is 2z to the power 5, 3z into z cube is 3z to the power 4, 14 into z cube is 14z cube. Okay, minus 2 by z, here z is there, so the missing terms are z square into z minus 3 the whole cube, so write it down, minus 21 divided by z square is there, means there is here it is z cube, so one z is missing along with the z minus 3 the whole cube. Okay, so z cube keep it outside, don't go to touch it. After that we need to simplify this. For that we need to substitute the z minus 3 whole cube, that we have already done it, that is z cube minus 9z square plus 27z minus 27, right. For that we need to multiply all the terms which we have got here, that is this term, we need to multiply by 2z square. While multiplying by 2z square, we get it as 2z minus 2z to the power 5 minus 8 plus 18z to the power 4 minus 54z cube plus 54z square. Okay, similarly here as well, minus 21z into z minus 3 whole cube, that the same procedure here, 21z into that term will give you minus 21z to the power 4 plus 189z cube minus 567z square plus 567z divided by z cube into z minus 3 whole cube. Again take z cube, here we need to simplify some terms, here 2z to the power 5 and 2z to the power 5 gets cancelled, and here 18z to the power 4 plus 3z to the power 4 is equal to 21, right, 18 plus 3 is 21, and also we have here minus 21z to the power 4, so these three terms have cancelled it out. So what are the terms remaining? This term, these two terms, and these three terms. Okay, we need to add them up. So 189z cube plus 14z cube minus 54z cube will give you plus 149z cube minus 567z square plus 54z square will give you minus 513z square and plus 567z as it is. Okay, yeah. So now here again we need to take z cube outside. See, here we took z cube outside and the remaining terms we have written, and here in the denominator also we have taken z cube outside, since there is already a z cube, so it z to the power 6, right, and we can cancel them and we can write the remaining terms. And after that finally anything to the power infinity, take the limit, anything to the power infinity is 0, right, so 149 by 1 minus 0 whole cube is 1 cube, that is 1. So 149 by 1 is equal to 149. So we have found the values for 1 is equal to 2, u2 is equal to 21, and u3 is equal to 149. Okay, this looks easy, but trust me, this is not an easy problem. You need to practice this problem very well. Okay, I have told all the steps in detail. Yeah, so that's all.